All right, we're gonna do some Lewis structures now, and these ones can have any number of bonds. So S2, there's only 2 of them, so we don't actually have a central atom there. So you're just gonna draw 2 of them with their structure. Okay, sulfur is in group 16, so it has 6 valence electrons. Okay, so you draw the 2 structures. We didn't have to worry about the central atom, as I said. And then we know they're at least going to be connected with a single bond. So we're going to take any electron from each side and draw it as sharing. And then we're going to check. 2, 4, 5, 6, 7. Well, that doesn't meet the octet rule. So that means I know I need to upgrade my bond. So I'm going to go up and make a second oval. And now I'm going to check. 2, 4, 6, 8. All right, let's check the other side. 2, 4, 6, 8. Okay, so it met the octet rule. Let's make sure I didn't accidentally add any extra electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it met its valence. So that is S2. That's again the process. So now we have to rewrite it. And instead of writing 1 bar, we have 2 ovals. So we have 2 bars. And what do we have left over? 1, 2, 3, 4. 2, 3, 4. And remember, you're going to show those guys as unbonded pairs. So don't leave it spread out how it is here. Okay, 1, 2, 3, 4. 1, 2, 3, 4. So this is a S, double bond with S. And our next guy, CS2. Okay, so now right off the bat, I'm going to think, yep, I think carbon's going to be the central atom, but I'm just going to double check. It has group 14, 4 valence electrons, so 4 gaps. So it can make 4 bonds. Sulfur, we just had from above, is group 16, so it has 6 valence electrons and 2 gaps. Carbon has more gaps, so it has to be the central. And you can also look at this, remember, molecules like to be symmetric if they can. So if I had carbon on the outside, it's not going to look as symmetric. So I have my carbon, I have my sulfurs, I put all their normal dots in because remember they're molecules. So they're not transferring any electrons anywhere else. They are going to hold their valence shape the whole time. All right, and we know they're at least going to bond once. So I'm going to take any electron from carbon and any electron for the left sulfur and make an oval. And I'm going to do the same with the right. They have to at least have 1 bond or else they're not going to be in a molecule together. And so now let me check. 1, 2, 3, 4, 5, 6, 7. Doesn't meet the octet rule. 1, 2, 3, 4, 5, 6. Doesn't meet the octet rule. So both of them can be upgraded. So I'm going to now upgrade. And now let's check this side. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this sulfur's happy. Carbon, 1, 2, 3, 4, 5, 6, 7. This carbon's not happy yet. Okay. And this sulfur is also not happy. So I'm going to upgrade again on this side. And now I'm going to check. 2, 4, 6, 8. That sulfur's happy. 2, 4, 6, 8. That carbon's happy. 2, 4, 6, and 8. And that sulfur's happy. Did I break any rules? Carbon can have a maximum of 4, 1, 2, 3, 4. Sulfur can have a maximum of 2 because it has 2 gaps, 1, 2, 1, 2. All right, I didn't break any rules. I still have the right number of valence electrons, so I am good to move on and rewrite. Double bond looks like that equal sign, okay, because each bar means 2 electrons. So kind of picture an electron here and an electron here. You're just making it simpler to write. And 1, 2, 3, 4 electrons are left over. And you're going to leave them as unbonded pairs. Okay. And my last one that I'm going to do is C2H2F2. Well, that's a whole bunch. That's 3 of them. Still works on that same process, though. Draw the electron dots for each one. Fluorine has 1 gap. Hydrogen, remember, is weird. He maxes out as 2, so he only has 1 gap. And carbon has 4 gaps. So that means carbon's in the center. Which carbon's in the center? Both of them. They can share it. And then where you put the H's and the F's, that's up to you. Okay, just make sure you're spreading them around. Okay, right. And let's put in our electrons. Okay, so carbon is going to have to bond with the other carbon, or it's going to be two separate molecules. Carbon has to bond with this hydrogen. Carbon has to bond with that hydrogen. Okay, and then this carbon over here is going to bond with the fluorine and with the fluorine. And now we have to check. Hydrogen's happy. He's 1 valence electron, and he's 2 with the sharing, which is what he wants. 1 valence electron, and he's sharing for a total of 2, which is what his maximum is. Carbon has 1, 2, 3, 4 valence electrons, but 1 is an electron by himself. This guy is lonely, so that guy is not happy. Same with this carbon over here, 2, 4, 6, 7, with a lone electron there, so that's not happy. Fluorine, however, is happy. 1, 2, 3, 4, 5, 6, 7, 8. He has his 7 plus 1 from carbon. Fluorine has his 7 plus 1 from carbon. So all of them are making sense except for we have 2 extra electrons. Guess what? We're just going to make a bond with them. Okay, and now this carbon has 1, 2, 3, 4 bonds. This carbon, 1, 2, 3, 4 bonds. The hydrogen's 1 bond. The fluorine's 1 bond. So I didn't break any rules. I have carbon can have 4, hydrogen can have 1, fluorine can have 1. So it's all making sense. I just need to rewrite it. Put in those 6 extra electrons on the fluorines, and there is my structure. Oops, let me move my camera down so you can see it there. Just to rewrite. C has a double bond because it has 2. All the other ones have single bonds. And don't forget to add all your electrons around fluorine.